Hello, everyone, and welcome to another stream. So this week we decided to make and ship a game as quickly as possible with a decent degree of quality. So the idea was to get something we were excited about getting in front of other people, and then after this week, we'll get it in front of people, get feedback, iterate on it, and keep making it better. So, right now, what we've been working on is a bunch of sort of like miscellaneous cleanup stuff. Uh, but the game overall is in a pretty stable place, and we're at the point where we can kind of just like really focus on level design and get everything to a reasonable degree of done, so that we can kind of get finished up and work on actually designing some of these levels and call it done for the week, right? So that's where we're at. And I can also just give like a little walkthrough over the game so far and how that's been going. So this is our little game. You can kind of just run around and jump. Oh yeah, you can also attack with your sword. Here's like an enemy. We're just going through some more grasslands. Oh, I see. Yeah, I do want to clean this up really quickly. So we actually only want a wall slide if you're moving down. Right, so it's a small little bug there. Let's see. Yeah, that looks a lot better. Okay, anyway, so we've got this plant guy you can kill. We just added directional attacks, actually, even though we don't have a sprite for it. So you can see, like, up attack, right attack, down attack, and attack with no direction. So we actually do have directional attacks now, and maybe that will make some interesting puzzles. It does make a secret move in the game a little bit harder to do, but I think it's a good harder, not a bad harder, because it means you have to actually have a bit more skill with it. Alright, one thing I definitely want to start doing, I'm going to make a note of this, is like add some background tiles to these scenes to start making them feel more real. So we'll make a note of that, and we'll just finish with this little demo. So then we've got some bats. Okay, more bats. I kind of don't like actually that we should introduce the bat where it's just one bat and then have the 3-bat room later. Now we're kind of combining some enemy types, which is kind of fun. This is like a leap of faith type level, so we just hoop. So now actually we can kill this snake. Like before we weren't able to kill the snake, but now we can just attack downwards, which is pretty nice. Yeah, we've got like these, I guess sort of like, oh, does that not work anymore? Okay, so interestingly you can't, oh, you can run across these. I guess you just have to get, it maybe isn't always deterministic. Oh god, we should fix that. Anyway, let's get back to where we were. Da-da-da. That one's kind of hard to pull off. Okay. Oh, we also got rid of our debug stuff. Yeah, I guess I don't really know. We can worry about that later. I don't know if we're going to keep wall sliding and wall jumps, but we've got them in there now. So maybe they'll make some platforming more fun. Maybe they'll break some levels, you know. But yeah, now you can do a little wall kick jump move, which is kind of fun. And that's the end of the game for now. Obviously, it's still a work in progress, but the thought is this will be kind of the overworld where we like slowly introduce you to the game, and then maybe it ramps up in harder levels later. Okay, so that's where we're at. I've got a bunch of random to do stuff to do, and we're just gonna like go through stuff and knock them out one by one. Okay, so the first thing we want to do is add a version number to the game. This is pretty easy. This is just to give like a good, like a human readable string somewhere. So if people come in and want to say, hey, I'm on this version, we can say, oh, great. What version are you on? So we'll just do it as a string. So this will be game version 1, and we'll say 1.0.0. And we could clean this up, move it somewhere, but for now it's fine. And then when we go to draw our debug overlays, we should make a label for this. So there's like a bunch of debug overlays, but we'll just make a note here, debug overlays, so we can quickly search for that. And then when we're drawing our build hash debug thing, we can also do string concat. We'll do version, the version string, game version, and then I think that's it. So we just want to do something like that. This game version we actually could convert to a string because it's just going to be a constant. Kind of like that. So yeah, you can see like, cool, we've got the version up in here now. And we're just separating everything with these like vertical pipes. Maybe we'll put the version number first because that's like what the user cares about. So we'll just say version, game version, a pipe, and then the rest of the debug string. Okay, so actually we need a new function, string concat. So we only have, you can concatenate up to 3 strings. What we want to do is make one where you can concatenate up to 4. So A, B, C, D, and it's really just we add up all the lengths of everything. A count, B count, plus C count. Oh god. A data into data 0. What's the pattern here? Okay, so A data into A count. That one is always the same. The second line is always the same. Third line, same. Okay, so it's just, we just need to say plus C dot count. And then copy D dot data. I kind of want to pull this out into like a count equals this, because why not? And we'll clean up these as well. So then you can just say count, data count, count, Okay. Count. Okay, so here's all of our string concatenations. 1, 2, 3. And then this can just be count. And maybe we want to keep that pattern going of like spacing all these out. Because see, look at that. There was a bug right here. CD. So it makes it just a little bit easier to catch that bug. Cool. And that's it. So now we should be able to do our string concat with 4 strings. And we get our version number in there. I kind of want to just put it on its own line, I think. Because version number feels important enough. So we'll just do if 1. This is in case we want to like conditionally toggle some of these. I don't actually think we will. So maybe really what we'll do is like kind of just do that. Give them all scopes. All we gotta do is a draw text at the cursor. The string is gonna be the game version. And that's it. And then we advance the cursor by the Y position. Oh, we want to label it version, just to make it nice. So we could do a string concat, game version, S version. Okay, so there we go. We've got our game version in there. We've got the build hash, what kind of build it is. This is like the build info, this is the draw info, this is the frame timing. So each line kind of has like a separate concern, which is good. I mean, users aren't going to see this really, but they'll be able to toggle it on if we want debug info. Okay, so let's just commit that. Add version number. Cool, so we can cross that off. Okay, the next thing we want to work on, I think the next thing I want to do is probably add some background tiles to the screens. So it's going to make it feel a little bit nicer to like come into this room if there's some stuff behind you. And I'm kind of running out of colors to pick from, so I might just start like, you know, making darker versions of these colors. I apologize in advance. Oh. It starts to get a little annoying with the way we've defined the editor, but, you know, because you can't have multiple layers here. So, like, maybe we actually did want the ability to do multiple layers, and then that would power us through using Aseprite. But for now, you can't do that. So, like, I can't put a background behind the player spawn point. Like, this white square is the player spawn point. Which is maybe fine. Like, whatever. You know, we're just going to try to focus on shipping. So, we don't care that much. Although, at this point, it starts to get a little weird with this stuff as well. Like, hey, these little grass tiles maybe get covered by the wall background. I don't know. I guess we'll just see how that goes. So we'll come into the game file. And we've already got like sort of space here to put background tiles, but I don't like any of the ones we picked. So I'm gonna maybe just do these tiles with transparency for now, and that'll be kind of the whole thing. Or something. Or just any darker version of that color, so whatever. This is good enough. Okay, and then we've got our bricks background. Maybe we'll make an entity call for this. Like, I want to put labels here where we can say like, hey, these are our hitbox collision. It's like a little annoying to jump around between these. So this will be like helpers, entity helpers. Then we'll have a section for like manager. Then we'll have another section for like collisions. And then we've got like all these other things. So this is like entity functions. And then all our actual entities, which kind of starts here. So, yeah, so maybe we want a function that's like create tile, entity tile. So we're actually using this like null type, which I don't love. We might want to just make a separate entity type for the tiles. Create tile. And I do want to clean up the way some of this works. Like I'm thinking these entity create, like this function will just do the instantiation rather than calling this that does the collection of stuff. It'll make building like a level editor easier if we ever get to that point. But for now, we're just gonna keep doing the thing we were doing. So we'll give it a default sprite. Position can just be whatever you set here. Tile. So then we can just say over here, well, tile equals create entity tile. We might even want these not to be, like we might just want to say create tile, because we might not want these to be entities in the future. But for now they are, so we can actually use place entity on grid. Okay, so we already used this value. It's not going to tell us where we already used it. All right. Bricks and brick background. Okay, so actually we don't have this color. This color is this. Okay, so now we've got like the brick background stuff coming in, just so that we can start making these levels feel a little bit more real. So let's do something like this. See, like your spawn point creates a hole in the bricks. But okay, I do want to change this brick color. I almost want to cheat and just use the bricks but transparent. I'm really trying to stick to this color palette though. So I don't totally know what will feel like a good background color. We're already kind of out of colors, but maybe this purple. Maybe. Right? And like, let's just see. Like if we just do the actual bricks texture, what does it look like? Ugh, that looks so much better. We might need to change our palette a bit so that we can use that color. But yeah, like just having it even remotely close to this red is so nice. The other thing that we could do is make the bricks brighter. Which could work. Like maybe the bricks already feel a little too much like background. I think this is why I pretty much settled on this blue color earlier. The other thing we could do is we could cheat and use hard black. Which also could look kind of cool. You know, like it gives the cave a special feel to it. Like, okay, we're in the tile region with these bricks. And yeah, maybe we'll do that for now. And we are technically cheating a bit though and using a stronger black. Maybe there's a gray that's like a lighter gray. We really don't have a lighter gray. So maybe we just cheat a bit and then we harden the palette later. Like, you know, something like that. And maybe we do just add this gray to our palette. Like, we don't need all these freaking blues. There's like 4 different blue colors. I don't really feel like this ramp is amazing. So I guess for now we'll just do this blue color, but maybe in the future we'll change the palette on it. Which is exactly what we had, but, you know, whatever. Okay, so now you can create these background tiles. We actually already had this color set to the background tile color, so let's just do that. We gotta select our bubblegum palette. It would be so nice if we could just use real Aseprite files instead of you know, maybe we can make this look a little bit like ruins. into Sublime Text. Oh, wrong project. Pixel game. Okay. What the heck? What just happened? Why? Why are you saying you can't read the file? It's right here. File, project, save project as. I guess it deleted. Maybe I deleted it in this other window. Okay. Sublime Text is killing me right now. Are you kidding me? Oh my god. Somehow we broke our build. Build.bat is not recognized. I don't know why all of a sudden it's not a recognized program. It was working totally fine. I mean, I can run it directly. Right? Oh my god. Sublime Text driving me crazy. Do I not have the build system set? Do I have to do that? Ugh, that's probably what I have to do. I really think they could do some quality of life improvements to this build system. We deleted build. No, it's right there. Okay. I guess we can try to figure out why this is broken all of a sudden. We're trying to ship a game, Sublime Text. We don't need your nonsense right now. Okay, so go into the folder that's open and run build.bat. Maybe we don't have the folder open. Maybe this should be project instead of folder. Okay, I guess that's the problem. Yeah. We could fix that. I don't want to work on it now, but it would be nice if this just worked with folders or projects, and maybe that happens. So, like, if I go file. Okay, so we're in the folder now, and maybe that's what that parenthesis means, and then I have to just say save project as this, save, yes. And now we can go, yeah, all right. Bit of a disaster, but we're good. It's too hot out today. It is simply too hot out. can use our secondary monitor as lighting. Okay. So where were we? We've got these ruins. And we don't love the color of them, but that's okay for now. You know, maybe like we actually want a color more like this kind of thing. Maybe I'll just make this change now. I think it'll make, yeah, that just makes the game look so much better. They didn't have any dark grays in this palette, so now we've got a dark gray. Okay, so you're kind of like coming out of this castle section. It's sort of like ruinous. Maybe we do just want to commit to the gray color. So we'll just commit to the gray color. Gray, and then in the world, game bricks BG. So this just has to be the gray color. Okay. So there we go. We've got some kind of ruin stuff. You're in this overworld thing. I like that this room is kind of open. I kind of want to shift it up a bit. Make it look a little more like a ledge that you're running into. Something like that. And then sure, yeah, you can fall down a bit and whatever. And then maybe we put a brick tile in here as well. See that? So it's like a little brick, a little fallen brick. And maybe we slide this whole background over. Yeah, this is why layers would be helpful. I'm really trying to avoid doing any sort of extra quality of life improvements with the level editor, even though we really probably want it for the next however long it's going to take us to finish this game. But, you know, whatever. And maybe this just kind of feels sloppy, so we can get rid of it. So, okay, we go through here. Yeah, I just like that this feels a little more open. Now, if we put the plant any higher, you wouldn't be able to jump and attack it. I do think we should try to fix, like, hey, attacking the plants feels kind of bad. Like, you move forward a bit. Oh, no, actually, you don't move forward that much anymore. So this is maybe totally fine. You know what I kind of want to do? If you take a hit, you're going to die and start back at the spawn point. Okay, we should fix this flicker. So we want to fix the flicker on screen change, and then I want to make a better live system. So make better lives system. So we'll do those two things next, because I think they'll make this game just feel a little bit nicer. Like, if I'm in this room and I die, I should just start back here. You know? Okay. So the way... Okay, well first let's fix this flicker, then we'll do that. So the flicker happens down here. We actually could probably just break this into a separate function call, but I think for now we're just gonna slide it under here. So all we need to do is like, because what's happening is the player is moving in Manager Update, and then you're in a new screen and the camera's out of date. So all we need to do is say update game transform. And then do the exact same loop again. Maybe we'll think a little bit better about doing these explicit level switches, because it's sort of related to the next thing we want to do, which is the live system. I'm going to implement a pause screen really quickly, because I think that would be just nice to have. And we already sort of implemented it, but I don't think it'll take that long. So we'll have a game paused, and that starts out as false. We'll have a pause command that comes through on the game input. And then paused equals keyboard pressed, key P. Yeah, P is usually like the standard thing for pause, right? Maybe we can make it escape. I guess escape feels a bit more natural. And then we want to also map a controller pause. So I think we have like a button start. Yeah, okay. So now that we get input paused, we can make a little function here that's like is any player pressing pause? And we're gonna actually shift this game input stuff up. Maybe I want to break this stuff out, this tile stuff, but whatever. So for now, is any player pressing pause? We'll just say, well, the input is game get player input, and we'll say incomplete loop over all players. Actually, that's easy enough to do. Let's just do it now. So we'll say for manager.entities. And we actually don't care if the player's alive or not. We want to let everyone be able to press pause. So all we do is just this, and then we say return false. Is any player pressing pause? And Oh, we want to say for find all of type. We definitely need to make these finds faster. Like, we should definitely do a performance tuning inspection. But, you know, it doesn't get us closer to shipping the game, so we're not going to worry about it for now. And then all we have to do is in-game update. Yeah, maybe we do want to move this nonsense. Maybe we, like, let's just pull this out into a function. It's getting, like, gnarly enough. Or we can just do something like this. Ah, we're just missing a bracket here. Okay. We'll have a thing here called game do world gen, which will just take in our world map. And here's some code we're not using at the moment, so we can paste it down here. So when we're doing the world gen, if we don't find a player, we do world gen. Generate worlds from map, I guess we could just call it. And then we'll just say world. And then this actually can go in here as well. So that's our active world. Input dot pause. Input dot pause. Okay, so now we got the key map in there for pause. Then in game update, all we have to do is say if global dot paused return, and then we'll say frame dt equals 0. Right, and then in game update, all we have to do is say if is any player pressing pause, global dot paused equals not global dot paused. So we've got pausing now. We do want to just draw a little graphic, and so we have a graphic for that. I'll just use my old one, and we can fill this in with a placeholder later. Oh no, we were generating files in this folder. I just delete all these. So these are super secret. I'm gonna move it onto this screen. And then we can paste it into our game. Game dev pixel game data paste. So we'll open this and we'll say file save as pause. .png. So now we've got our pause. And all we need to do here is just make this use our color palette. So we've got the black to kind of make it pop, but that was on a game that kind of had more colors than what we have. So maybe we'll have like a theme color and we'll use the theme color. Whatever. We're not going to worry about it. Are these whites the same? No. It's not the same white. So yeah, we've got the color from our palette. Okay, and then all we have to do is in game update, in game draw, we're going to draw the whole world, and we'll say if global.pause. So basically just, you know, find the center point. Game size. We'll say sprite equals load texture. Pause. Center is this. And then all we want to do is say we'll draw in the camera space from .5, and of course we want to draw our thing. D2 sprite texture get size. So we could make all this a little easier, and maybe we will do that right now. Just make like a sprite draw function. Camera to screen does not take 0 arguments. That is correct. So we've got our pause text in there now. I'm going to take a quick break, heat up some coffee, and then we will do more of this stuff. Okay. So now the next thing we want to do is make a draw sprite function. Just to kind of clean this up a little bit. So I was actually thinking like sprite is kind of a game concept. It's not really. It's like not really a render concept. But whatever, we'll put something here for now. Draw sprite. So basically draw sprite is going to be a lot like draw font. Like, it's going to take a vector to position, size. Maybe size is actually just picked from the sprite itself. What do we do for fonts? So we take position, color, vector to anchor, and a vector to scale. And we could do rotation, but we're not going to do rotated sprites. So then all we have to do is say, well, get the size of the actual texture. It's kind of basically the same as we do with the entity bounds, where we say like, okay, size times absolute value of scale P0 equals position plus minus anchor times size. And then that just creates a rectangle. I think we really want to have like a math function for this. We do this so much. I guess it'll be a rectangle 2 function. Just somewhere down here where we're like, look, compute, let's say like make bounding rectangle, make rectangle bounds. We'll just copy the order here. So position, anchor, 0, 1. And all of this function is going to do is like the same thing we do everywhere. But now we don't have to make functions for it all the time. I feel like I was just repeating this code a lot. So we can say scaled size and P0 is position minus anchor times size, size times absolute value of the scale. And then we just return that rectangle bounds, make bounding rectangle. Make bounding rectangle. I don't know, make rectangle bounds, that's fine. So then all this can be is just make rectangle bounds, position, it size, it anchor, and it scale. So the entity actually just has like everything it needs to do this. And we'll ask the compiler to please inline this function if it gets to it. We don't know if it will, but we hope this does. I guess we should just pause here and make sure nothing's totally broken with the game yet. So let's just run. So this is actually this, because C++. Oh, well, we actually could just get rid of it now. We can just say that. Okay, we do have a bug. So the goal is to figure out what's different about these two. Because we have to do scaled size. Duh. And we could also make a helper for center. And a inline vector2 get rect bounds get rect bounds center. Maybe we'll call these like bounds get center and like get center bounds. It's kind of like one concept that we're just using in both places. Get center bounds. And this is just the same thing, except we return this instead. So this is a pretty decent refactor. It's nice to finally improve stuff. So scaled size is size times absolute value of the scale. Position, anchor times size. And then we might even want these to be, like, maybe we'll put like a robustness. Because we might just want them always to be in like normalized coordinates. You can technically have a negative rectangle that represents the same thing, kind of. Okay, so our scaled size. So scaled size. Maybe we just make this like actual size. Because I keep messing up that. Redefinition of pos is, we call it P0 here, so let's just keep the naming the same. Okay, so that is good. Get center bounds, and we will say position, size, anchor, scale, and this we'll call that. Okay. Right. Oh, we're just not using the right, this should be P0. We'll just do like SS. Okay, so now we've got that working. That's good. We're gonna switch to our sprite drawing, And now all we need to do is literally just call this function, right? So what this just becomes is a draw texture. That's it. Oh, and we also want to use our color. Texture get size not found. What is texture get size? This is actually a render thing. Okay. So now we've got this nice draw sprite function. And what we want to do now is just do that, right? Draw sprite in the center of the screen. And we can just use this like function now. We don't have to compute all these bounds of everything. So we want to draw in the center of the screen. We're going to make it white. Kind of want to put color last here. Anchor. Scale. So that works. But the problem is the sprite is in the sprite's in so the sprite's in game coordinates, right? We need to still do camera to screen. Maybe we'll have another function called like draw sprite bounds. And this can take the bound points, and then we can just get the size of the sprite. Draw sprite bounds. I mean, yeah, basically the same exact thing, right? Hey, Elite Monkey 038. Yeah, it'll be fun, they said, and it turns out what that translates to is us just making a game engine. So it is pretty fun, actually. Like we built the whole engine ourselves, and it's been going pretty well. You just have to do all the work, so it does get to be a little hard. Yeah, well, so we made the game engine before this week. Like, we're finally just saying, hey, let's stop making engine features. Let's put on our I want to ship a game hat. And we'll fill in all the gaps in the game engine that we're missing. But, like, the focus is finishing a game, not doing explicit engine features. So, like, right here, we're working on Draw Sprite, which is an engine feature, but it's also like a quality of life improvement, that kind of thing. So a mix of both, but I'm trying to like really lean towards like actually shipping a game and not really care too much about doing things like the correct way and only refactoring code if it actually will save us time, not if we. You got 3 more days. Yeah, we do. We do. I don't know. Yeah, it like we've got mostly a working game here actually. So like we are kind of working on the final phases, and then uh yeah, my day's been good. I can show you what we've been working on so far if you're curious, but I do want to just finish this function really quickly. Uh, we woke up kind of late because we were up pretty late last night working on game stuff, getting some early play testers, and okay, yeah. Let me just comment this out really quickly. So it's designed to be a pixel art game. Like if you've played 1001 Spikes or VVV, it's like in that style of game. So, I'm not a pixel artist, but I made all this pixel art myself. Um, and like, it's kind of like basic platformer mechanics. You can like jump, you can sword slash. We actually added this today where you have directional sword slashes now, even though we don't have an animation for those. And then like, okay, here's our overworld where you're just getting the feel of the mechanics. You go over to this screen, there's like the first enemy, which we need to fix this enemy image. It looks kind of bad, but it's what we got for now. And then you can kind of like run on over. So it's very simple, like just kind of teaching you the basics of the game. And then, okay, now there's 2 of them, and it's like kind of in this pit, and that makes it a little bit trickier, right? And this area needs, like all of these areas need work, right? They're all kind of very placeholdery levels. But then we escape the forest section and we get to like this cave level with these bats. And this is, yeah, again, kind of placeholder content, but we've got a bat enemy, we've got this plant enemy, and we have a third enemy type, which is this snake. Thanks, yeah. And so what we added this morning is actually like the ability to crouch shot. So I can turn on the collision volumes and you can see like, here's a normal sword attack. And then if we do a crouch shot, you actually, like your hitbox goes down. Yeah. Thanks, yeah. We've been trying to just get the right balance between getting the thing done and I actually have a lot more tiles that aren't even in these maps yet because a friend's been helping out do some map design. This is all the maps I made on like the 2nd or 3rd day, and then like this is the end of the game so far. But we've got a bunch of other maps that I can demo maybe a little bit later. But like we have spikes that will kind of like go up and down, and then we've got like trigger spikes. So I can show you quickly like a trigger spike. Yeah, our editor is actually just a sprite editor, and that's how we've been doing this game. So, because again, I was like, look, I want to finish a game in a week. Normally I'll like go and make a level editor in the game engine, but a week just really didn't seem like a lot of time to justify that. So this is all C++. We do a minimal amount of C++. It's mostly just C code. We do use some C++ features, but mostly it's just C. I never really got on the Rust train, and I like the simplicity of C. It is a little clunky for sure at times, and like macros are kind of bad, but kind of the only metaprogramming thing you've got. So let's see. Okay, yeah, so you can see these trick spikes, right? They kind of like appear and then pop up, and so we've got a bunch of other tiles that like we're not using at the moment, but oh, I've got two of these worlds open. Okay. Yeah, and if you have more specific questions about the engine, I'm happy to talk about how anything works. But it's all handmade. We use a really small amount of libraries, so you know we've only really got the color. Yeah, it's good to a point. Like I definitely think I'm hitting the limits of working in a sprite editor. So the game is based on this 16 color palette, and you know we ran out of colors. So now I have to like make different colors mean different things. Like we've got here's our like generate world from map function, which just literally says, oh wait, generate world from map. Right, so this just like literally takes an image and then goes through pixel by pixel and places tiles. And there are some weird edge cases and quirks to it, but we were just trying to finish a game in a week, so I didn't want to spend too long on the editor. And this seemed like a good trade-off. We do lose out some stuff, like it makes certain things a little more awkward than they need to be. So for example, we've got these like which I don't even know if this will work. Let me do it in a space where I know it will work. So like we've got this texture, and it actually creates a fake wall that you can like walk behind, right? But like how does it pick the color of the wall? It kind of just samples like the first thing underneath it, which is this block. So like, you know, there's not really an easy way for you to say what you want the fake wall to look like. If we had an editor, we could really like just make it an option where you pick. See, now it's grass because I changed that one tile. So there's some weird quirks like that, and I guess just kind of looking at this image and looking at this is a little different, but you've got F5 to reload, and so it's pretty fast in terms of iteration. I think probably we'll want to... I have an old level editor that, you know, if this is going to be a game that we like make in a week and then polish over a month, I think for the polishing step, it might be worth investing a day or two into retooling some of that old code into this new system and then using the new editor. And we can port all these levels into that. But anyway, so that's like a overview of how the editor works with map tiles. It's pretty nice, except the drawbacks we just talked about. And yeah, if you have any like specific questions, you want me to look at certain engine things or how do certain game things work, I'm happy to talk about any of that stuff as well. But if not, I'm just gonna keep on going. So we want to make a draw sprite function. And we've already got a bunch of draw stuff. Like we've got draw texture, but specific questions, like you expect me to know anything about code. I don't know. I mean, I just kind of thought, hey, if you're joining a programming stream, maybe you know about code, but at least there's some interest here. So like, are you thinking about learning how to program? Or are you more just like curious to see how other people do it? Like, what are your learning goals, I guess, generally, and specifically for watching this stream? I can also just talk about whatever. So like, if you're just like, what even is code? Or like, even the most basic questions, I'm happy to answer. I've been programming for like 18 years, and you know, you make a lot of mistakes, you learn a lot, and like, it's nice to be able to explain things back to people if it can help them get started or whatever. So, or are you more here just because like you're interested in the game side of things? Because that's also great. Like, you know, we need some play testers. We need people to say like, what are the good mechanics about this and what are the things that could be improved. Okay, so we wanted to make like a draw sprite function, and specifically the way we want to be able to call it is something like this. So we made our first one, and now what we're saying is we need another one. So we want to actually like remove all of these things and just say, hey, you can give us a rectangle. I want to learn Java. I had simplified Java and made Flappy Bird in it in processing. Just very bored. Okay, well, if this is at all entertaining to you, then I'm happy to provide that entertainment, but why did you want to learn Java, and like how did that go? Yeah, I feel like Java is kind of a weird language to get started with. Not too many viewers because more streamer viewer connection. Yeah, for sure. Yeah, I'm still starting out in my streaming career. I've been doing the programming thing for a long time, but I felt like at some point it's a tool for me to just like get me motivated. Like if I'm streaming, I have to be doing something, and if other people could learn from it, then that's cool too. I feel like I've definitely made a lot of mistakes and sort of done the same things multiple times, but I think I've kind of gotten into a good flow now, especially with this game and the state of everything. But yeah, Java's kind of rough. If you're just trying to learn programming, I think GameMaker is actually a really great tool. Like, that's what I got started programming in, and it teaches you object-oriented programming without even really you thinking about it. Java's just like, okay, we're going to go 100% object-oriented, which a lot of people say these days are kind of like, and I agree, object-oriented programming is kind of a bad way to learn how to program. Like, it's fine. Like, however you do it is fine. It just means down the road you have to unlearn some stuff. And I feel like I've had to unlearn some stuff because GameMaker kind of starts out as very object-oriented. I had the simplified Java through school, and I feel like going Python or C# will make me start at the bottom. Yeah, I think that's fair. Like, if you already know a language a decent amount and you're just getting started, unless you really feel like you're fighting against the language, I think you're right. Like, you will kind of have to start over a bit. I think it's once you get a certain level of competence with programming, you can switch between languages like without really thinking too much about it. Like I can program in pretty much any language, like even assembly, although I don't do assembly programming. Like it takes a little bit of time to like you almost look at like a cheat sheet or something, right? Depending on how long it's been, and you're like, oh, how do I do this thing in this language? Because all of the concepts are the same. Like I'm sure Java has like function return like types, and it has function names, and it's got if statements, and so like maybe this doesn't totally look like Java, but like all of the main concepts of like functions and statements and loops and variables, like that's all here, right? I think Java even has like an auto keyword now. Maybe it's called var. Because you used to have to type like if you had a crazy class like my business class printer, you know, you'd have to like type out the class names. So function in Java is basically void main. Yeah, I guess you're just talking about function versus methods. I don't really like. That's another one of those things. Like, there's not too much of a distinction. Like, object-oriented programming is just a function that is associated with a block of data. And like, you can have functions that work on blocks of data that are not a part of classes. Yeah, but if you want to like. If you want to do a function in Java and you want it to be kind of pure, then you probably have like some sort of static function or something. Because otherwise, if it's an instance method, like you could go nuts and like, yeah, so it's pretty similar, right? Like void game draw. Like you could have a class, like you could have a function like this in Java. You would just have to wrap it in like public class Java class and that. And maybe you would need to say like public static void game draw or something, right? Like, because like if I want to invoke game draw, maybe I'd have this called game, and then I'd say like game.game draw. And then I don't need to create like an explicit instantiation of this class or whatever. So it's like pretty similar, but yeah, if you think it's gonna set you back too much to switch, definitely just keep learning and getting better at that, I think. I mean, I don't know. I don't love Java, but I think you can still do good things in any language. And hey, Minecraft was made in Java, right? So like, there is a very high floor. Except if you do make Minecraft in Java, then everyone's computers are gonna like burn a ton of like compute power all the time. But whatever. And use a ton of RAM. That's one thing, like, I know you're really early on in programming, so I don't want to scare you off too much, but Java, like, you don't have to think about where your memory comes from, right? You just say, like, hey, give me a new game. And you just have a game, and where does that memory come from? So it turns out your computer has a physical thing that stores memory, and I could basically keep talking about anything forever, so, like, you gotta kind of tell me what's interesting to you, because otherwise I'll just keep talking. But, you know, some concepts in Java don't map directly to how your physical CPU works, right? Like, there's somewhere there is a rock that we've tricked into thinking by doing lots of math operations really quickly. And that rock has real limitations and, like, real ways of dealing with actual physical bytes, right? Like, these aren't, like, abstract things, like, and that's, I think, where a lot of the object-oriented mindset kind of gets a bad rap. It's just, like, it's introducing all these other concepts that, in some ways, don't really have anything to do with what a computer does. I didn't even use functions in my Flappy Bird. I set up Unjet 60 frames a second, which you can change with frame rate. Yeah, like that's the type of programming that I like to do as well. Like I kind of went through a cycle where, like, I started out just doing straightforward code. I got to a point where I was like, oh, I could, like, do cool object-oriented stuff, and I did that for a while, and then I'm like, okay, actually, I have to unlearn a lot of that object-oriented mindset. I've got to, like, really just get back to writing straightforward code, because it's so much easier to debug. It's worth exploring in programming, like, having different modes of thinking. Like, I'm just going to try this out and see if it works for me. You know, like, I'm telling you what works for me and what I've tended to like, but it's totally, like, whatever works and whatever gets the thing on the screen is all that really matters. All the other stuff, like refactoring code and, like, making even just, like, data types for stuff, all of that is, like, quality of life improvements that you, like, can iterate on. So, like, with your Flappy Bird game, okay, you've got one function and it's Flappy Bird and one function. That's totally fine, right? You start at the top, you load, like, 4 textures, you go draw. What were you doing for the drawing in Flappy Bird? Like, were you using a graphics API? Like, how are you getting the squares on the screen? Was it just, like, Java Swing? Or, like, I don't even know Java UI programming. It's been so long. But somewhere you had to say, like, hey, I want to draw an image, right? Like, you had to tell it, I want to draw an image at this position in the window. And, like, I don't know, maybe it's been a while, so you don't totally remember, which is totally fine. But yeah, there's, like, all this... Right, like, in your Flappy Bird game, you had, like, that one function. You had to, like, find images from disk somehow, like, by file path, and then you had to, like, tell the program to draw them. I don't know. Maybe it's been a long time, so you just don't totally remember, and that's all fine. I was just more curious. Okay, I'm gonna try to get back to doing some of this stuff. For the pictures, I used a library. For the pipes, 2 rectangles. Yeah, okay. You can just draw with rect. Okay, interesting. Java rect. Oh, okay, so this is like the AWT. I don't know what AWT stands for, but... And I guess there's some way for you to tell. Yeah, this is kind of like the code that we've got here, right? We're just defining it ourselves. But like we can go through and say, like you were saying, okay, rect, we've got a function here called draw rectangle. So totally the same thing. Yeah, I think rect is a processing call. I think you're right. So I've only used processing in like C or Arduino or something. Maybe it was actually JavaScript. I don't know. It's been so long. But yeah, I know that they port their functions to like a bunch of languages. So yeah, if you're just doing like processing stuff, that's totally a great way to start, I think. Saw a code bullet. Use it to make some nice stuff. IntelliJ. Okay, yeah. I use Sublime Text. I've just kind of like realized I don't need a lot of fancy IDE features. It's got enough of the basic stuff where I can like, you know, say like find a function with this name and I jump to it and it's got like basic function name completing. It's really all I need. And I like that it's fast. Like I don't have to ever wait for it to start up. Okay, so what we want to do is just finish implementing this draw sprite function. And we're going to kind of just copy this and work off of it because it doesn't really make sense to share the code. So you're going to pass us a texture, and then instead of doing this make rectangle bounds, we can actually just take in whatever bounds you told us. And let's see if that works. So yeah, okay, that's exactly what we wanted. All right. And I don't like the pause sprite per se, but everything's placeholder graphics. I don't really understand the Java from IntelliJ. Okay, yeah, so Java is a programming language. Like, the language is just text. Like, I can write a text document. Right? I can open up, like, Notepad, and I can type some stuff. That's Java. Java is a definite, like, it's both a language specification, and a compiler. So, like, I can write some stuff here, say this is my, like, amazing Java program, and then I hand it to the Java compiler and I say, like, hey, turn this into a program for me. And that step of translating text on your computer into actual machine instructions is what's called a compiler. So every like language is sort of like you write text and then there's a compiler or an interpreter, right? Like JavaScript and Python are interpreted languages. I know, but processing is really similar to Java. Yeah. Well, like IntelliJ is just like letting you use all the other features of Java. If you're just using processing, then maybe you're stuck to only the processing functions. I don't know if there's a way to like interoperate between, like, I'm writing Java code and then I've got IntelliJ code or something. Yeah, there's just a lot more stuff, right? It helps to keep your scope simple when you're learning. There's just so many libraries these days. Like, that's why it's like you were saying earlier, like it's probably good to just pick a simple thing and stick with it. I don't know if Java's the simplest thing to learn in. Like, maybe there are simpler platforms. Right, yeah. So, yeah. So those are actually maybe just like two separate languages then. Like, if you can just write like, okay, void update and then do stuff, that's not Java code. Like, you can't run this text through a Java compiler. You need to like decorate it in like, public class. You need to do something like this at the minimum. And then you could run this through Java. Like, the Java syntax understands this kind of thing. It doesn't let you do this kind of thing. So yeah, I think you were actually just using two separate languages. Yeah, I wonder if processing just like implements its own. Because I know there's like processing JS. Let me just look at the site. So documentation, reference. Here, we'll pull it up here. This looks a lot like they're defining a language to me. It could just be sort of both. Like, how do I just... Okay, environment. So you need a processing environment to do stuff, I guess. Like this kind of thing. Yeah. So this code, like, looks a lot like C code, actually. Like, int bar thing. But I think they might have just defined their own language, and then they have, like, backends for different platforms. I think that's what they did. Okay, and then here's some stuff with, like, Java code in the processing environment. So how does this work? Interesting. Yeah, it is kind of confusing, the difference between the two. Like, I feel like I'd really have to, like, dig into, like, what is actually the user interface. Like, maybe they implemented processing in Java, or they have... Because there's also, like, processing JS, which I thought you could run... Oh, PJS? Yeah, this P5JS. So maybe this was just a library built that looked like processing, but is specifically for JavaScript. So how do I just learn get started? Right, like these functions sort of look like the Java processing functions. Sort of, but here it's more like C style code, and here it's more JavaScript style code. So I don't actually know with processing specifically if they have different language backends, or if it... Yeah. Yeah, it might just be that processing only implemented... Well, okay, here, there's all this stuff, right? There's like P5JS, there's processing Android, processing Python. I think maybe it started out as Java. I don't know how it started out. I don't know the history. But it looks like they implemented multiple backends to this API. And so, like, you can go into here and you can say, I want to do Python processing, right? Which is now I'm writing Python. But all of these functions are the same kinds of functions. Like, it's always going to be called setup. If I'm in Java, if I'm on Python, like, here, I don't know how to go to the... maybe we can look at the Java one. It's kind of hard to find the Java one. Android's close enough. You see what I'm saying? Like, it's here we're writing Android code or Java code that compiles on Android, but it's like Java syntax, and then here we're writing like Python code, but the names of all of the processing like primitives, so there's always a setup function, there's always a size function. All of these functions are kind of... It's like the pattern of like name function and like the tools you can use is what processing is. Which is cool. I mean, I think it's nice that it's relatively pretty simple. I do feel like there are still some things that beginners will get stuck on. Like, I don't know if you shared these experiences, but like, there's a lot of syntax stuff. Like, if I'm in Android, I've got to always say void setup. Well, what does void mean? Some variables may... Can I send my code in chat? I think you can post a link to like a GitHub gist or something. Like, you could paste it somewhere and then paste a link. Are you Dutch? I used to have a friend growing up that was Dutch, and I've heard great things about the Netherlands, but I've just never been. Okay. So maybe something like that looks good enough. You know, it's simple. It gets the point across. We'll have to put like some menu options here so you can actually go back to the title screen. So that's another thing to do. We can add a menu screen to this. What are all the other stuff we wanted to do? Yeah, okay. I think this better live system is something I should definitely invest in. And I want to implement like these little secrets that you can collect. Just because I think that would be fun and like an extra challenge for harder players. So let's do that in reverse order. Like let's commit this, I guess. I don't know, whatever. Add pause screen, right? And what we want to do first is add these little like collectibles for you to get. So I have a placeholder sprite for this. We've got this like strawberry thing. That's this is what it looks like for now. It's not amazing, but whatever. The reason I called it strawberry is just because like that's what they were in Celeste, right? This game is kind of styled after like the Pico 8 version of Celeste, not the full version of Celeste with all the fancy graphics. But there's only so much we can do in a week. But we want to create like these collectible types. So the first thing we gotta do is to define a color because we decided to make custom colors for everything. I don't know. I feel like I'm really running out of colors at this point. Maybe strawberries can be some sort of pink, but we can't use the pink in the palette because that's already used. Maybe it'll be like a light pink, this kind of color, right? That's good. So we'll go into our generate worlds from map function, and it's just a big function with all the different colors. So we're gonna do a couple things here. So first we need to go and create this entity type. I sort of have this sectioned off. I don't know. All right, here's some enemies. Let's just add it here. This is as good of a place as any. So for strawberries, I think we want to make sure they're on a 16 by 16 grid. This is one of those weird caveats about this system, but strawberry create. And then we'll say place entity on grid. Now we've got to go define actually a strawberry. Okay, so we've got a new entity type. Then what we've got to do is create all the functions that we want to use. So we want to say entity create strawberry. And this is literally just what we like made up over here. And then we're just going to say, so create an entity of type strawberry. And then just return it. And we'll set some default properties. Like we generally want to set the size, the sprite, some stuff like this. Right? That's all we need. And then we need, every entity can have optionally like 3 functions. It's like a create, update, and a destroy. Kind of similar to processing. Can I open this? Yeah, we can check this out. Okay, yeah. I don't know if you want me to share it on stream or not, so I'm just gonna look on my second monitor. But Okay, yeah, sure. I just don't like sharing code without people's permission, you know. So interesting. Yeah, yeah, this is totally reasonable. Um, this is like the type of code that you write when you're trying to just get stuff done. And I think when you program for long enough, it starts to be like if you worked in this game for a long time, maybe there are some things that you're like, it'd really be nice if I had like my own version of a processing function to just do this thing. Like I always do these like here you've got, you know, these three things always sort of happening at the same time. Well, they're sort of different. P1, yeah. So sometimes there is a cost to specializing stuff, right? Or to like making a function out of stuff. And like the specialized version where it's like everything's just exactly what it needs to be is easier in some ways to just edit and change, but then you can also have weird behavior. So you know, it's a balancing act kind of. But I think totally when you're just starting programming, like just get the thing working. So yeah, like processing is totally good. However you can get the thing done, totally good. And I think like over time you'll learn these concepts incidentally the more you do it. Like, oh, what's a float? What's an int? You would probably already know that because you've used the different ones here, but like what actually are they on a computer? And there's all these other stuff you can like dig into. Um, but yeah, pretty much the end state of our game engine is a lot of stuff that looks similar to this, right? Like we have our own load image function. We have our own version of sound loading. Um, but the difference is like I have total control over how that whole system works. So we can actually like do special optimizations. Like nothing is hidden, so we can actually like make everything increasingly better. Although it probably starts out worse. Float and double byte signed. Any I missed? Well, it depends kind of what you mean. Um, because bytes like it depends like at what level you're asking. If you're asking at the language level, like what exists in Java or C++, then yeah, like float, int, double byte, single. I don't know. Is single a single floating point value? Yeah, different variables to store numbers. I mean, it's all just numbers somewhere. Like when you've got a object in memory. I mean, even strings are just numbers. I don't know how far down. Like, I guess you missed strings is one type normally. It was in the video I was watching. Yeah, good. I mean, I think it's important to really, like, if you're trying to get better at programming, try to bias towards writing more code. And it's good to, like, have a balance between, like, you know, not biting off more than you can chew and also maybe learning some new concepts and trying them out and strings for words, booleans, yeah. Yeah, so C++ is kind of similar. Like, I actually define my own types here, but like these are all the types in my engine that you can just declare. So we've got like U8, which is the same as byte, and F32, which is float, F64. So stuff like these. And then we've also got like sized booleans. So you can have a B32, which is a boolean of 32 bits, and just some min and max stuff. And then we've got like other stuff. We have arrays, which is a custom fancy thing. We've got like strings, we've got a hash table. We've got like the works in terms of data structures. Basically to make a game all you need is like arrays and minimal hash table stuff. B32 you can save multiple. So that's a kind of a complicated answer. I can give you the short version because I don't want to go down a path that's like, there's a lot to unpack with that question. The short of it is not easily unless you do a lot of work. So the short thing is like, say I have a bool 32, or in my engine I have a B32, and it's going to be set to like false. Now technically I can set this to like a 0, a 1. There's not really any difference to the computer. I can also set this to a 3. So if you want to store 32 booleans in a 32-bit number, what you actually have to do is say, well, my x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You know, like if that was 32 ones, now this is a boolean with all of the bits. This is how you define like a bit string. So this is just a number with all the ones set. You could also figure out what that number is. But the short of it is you have to select out the bit that you want. You don't get this for free. Computers only operate at a 32-bit register size and increasing from there. So there's like, yeah, exactly. So like if you want the computer to go fast, you really only get one boolean with a B32. That's why you might want to explicitly say it's a 32 instead of an 8. When you're dealing with file stuff, file and network stuff, you generally care more about the size on disk or in memory. And if you're running at like 60 frames a second or whatever your frame rate is, you're generally caring less about how much space it takes up, but more about how fast it is for your computer to execute. So I don't know if that makes sense, but like, that's the short answer. Hopefully that wasn't too much. Oh, no. You just didn't want to listen to the description. I got it. No, it's fine. You can go back and rewind and listen to that blurb, but the short answer is just like one is faster for your computer to execute and one is more space efficient. And there's kind of a trade-off there. Without going too much more into detail, that's the short answer. Okay, so we've got this like strawberry class now. Yeah, that's all you need to know for now. It's good to have an idea of these things, but I think it's also important to not bite off more than your brain can handle at a time, you know? And like that's the cool thing about being new to something is you really can see your progress like, you know, daily or weekly. I feel like for me, because I've been programming for a long time, I have to like really try to improve my habits. Otherwise, I'm kind of just stuck in the way I've always done a thing or stuff like that. So it takes a little bit of unlearning. Like sort of the deliberate practice thing. Okay, so what's up with this world? Are we even seeing this block? The old printf debugging. So we do get to the strawberry block. Oh, it's because we didn't, oh my god. We didn't tell the strawberry to do anything in its draw method. And the reason I overwrote it is, well, actually we don't need to override the draw. We can just use the default draw, which will just draw the sprite. So there we go, that's our strawberry. So now there's two things we need to do with the strawberry. I want to give it like a fun little animation where it kind of like levitates in place to make it feel special. So let's do the levitation. I don't love that I have to like synchronize these variables all the time. I didn't want the like entities to really have to care too much about game stuff, but there is a point where it's like, look, they just kind of have to know some game things. So maybe we'll define like a small structure for them to communicate over. But for now, we'll just say like hey, entity time is global.time or frame time, whatever. Maybe we'll just call it like entity time to make it hopefully slightly less confusing to us in the future. And we'll put like a note here as we come back. Okay, so now that we've got like the time, so the game's just marching forward in time, and we can just pick out sine value from entity time. And we're gonna wanna like tweak this, like tune it a bit to make it kind of, you know, not too crazy. So the amplitude is gonna be like how much of this anchor point we're picking, and the time value is gonna control. See, like that's really slow. You can kind of see it's moving, but it's really slow. So like let's go by, you know, divided by 2. So it's doing like a little thing. Still really slow actually. So time is actually time in seconds. Maybe we want to do like times 20. Okay. Okay, too much. So every 4 seconds it completes like a full sine wave, which that starts to feel pretty good. You know, like this is looking a little magical. And like we can see it just kind of hovering in midair there. Maybe it'll kind of like move towards the player if you're kind of close to it. I don't want to go too crazy with this, but that's simple enough. So we can have it just like subtly go closer to the player if there is a player nearby. Okay, so if we've got a player nearby us, I'm gonna do just like the most basic thing here and say, just move our X position a little bit. Oh, well, we didn't actually say how that would work. Like, we need a state where it's either close or it's not close. So we need to look at the distance. So we can say some sort of factor. Yeah, like we have to make sure the player actually exists. We're gonna want this to be dynamic, but for now, if the distance is less than 16 by 16, so it's distance squared, so we just have to multiply, then we'll just set our anchor to -1. Okay, so it kind of works. And we want to like have a case where we unset it. Maybe we do that here. So it kind of works. We should turn on this to get a better. Well, okay, what's confusing is actually this offset actually changes the center point. So we probably want, like, I've been kind of punting on this idea for a while, but like, we've got an anchor. We probably also want like an offset that doesn't affect, like it's just a visual offset. So maybe we'll have like a thing called like visual offset, and we can go ahead and like implement that. I just want to think if there's like any other way I could think of doing this without introducing a new concept here. All right, well, let's get the like feeling of it right first, and then we'll do this offset thing. So in terms of feeling, we'll just work with the scale. And then we'll change that back to anchor, or like whatever the visual offset's going to be. And maybe we'll just set it to 2. Maybe we're not using scale in the entity draw. Okay, let's do the visual offset thing. So visual offset is going to be this new thing, and when we go to say draw entity sprite, we're going to shift the bounds by whatever the visual offset is. So all we have to do is say bounds plus it visual offset. And then let's just like test to see that that even does anything. And hopefully does. I don't think it'll break anything. So then in our strawberry, we'll just say it visual offset equals v2 8. So we're just moving 8 pixels to the left. Okay, so that works. And see, like our bounds are still actually that. The difference is the red rectangle versus where the sprite's being drawn. So the red rectangle is where the game thinks this object exists, because that's like literally where I placed it on the map. And we want to like just visually shift it towards the player. So that's all great. And we just want to make sure we're resetting this point back to 0. Because if you go outside of this distance, we're also going to want to bump this up a bit. Because we're going to make it like a fall off effect. But now we can just start to get a feeling of like, oh, we're in bounds, we're out of bounds. So then the last thing to do is we kind of want the visual offset to be based on the actual distance. So I'm going to switch this code instead of doing distance squared, because we lose signedness with that. We want to kind of do something like this, where we're just doing like the actual difference of these two things separately. And then we can just compute the distance squared manually, which is exactly what that function does. We'll want to clamp the position, so I might not even put in this, like, this is kind of an optimization, the if part. So let's just say our like visual x position is going to be dx divided, like, times 0.5. We're going to have to play with this a bit. And I don't know which way exactly the signedness is going to have to go. But like you can see now, it's kind of like following us a bit, which is kind of what we wanted. We do want it to not go too far outside of its bounds. But like it just starts to give it a little bit more of like an animated feeling to it. It just feels a little more interactive. Like it almost like suggests to the player like, hey, you can maybe interact with this. So let's just break this down. Like I'm only going to focus on the X position, and then the Y will be exactly the same. So, I mean, we could even sketch this out if that would be helpful, but we've got like a point here. Let's open Milton. So we've got like our point where the strawberry is, and then we're picking out the player point, and like these are separated by some distance. So say this is actually our origin point, and you know, this is like where the strawberry is going to be drawn. We want it to like fall off as it gets further away. So meaning the weights will be less. So we know this distance is like dx. And I think what we could do actually is just do something like dx divided by times dx. This might not be totally correct, but I think we can take like the magnitude and then multiply it by some pixel amount. And you can see it's like just barely doing what we want. Okay, and it goes a little crazy in the other direction. But huh. Let's just say we're gonna have a max. Like, so we'll clamp dx. We'll only do the positive x direction first. Then we'll do negative, then we'll do y. So I want to clamp dx between 0 and 32 pixels. That's like the max distance you're able to go. And we need some sort of like smooth blend that falls off. So that sounds a lot like a lerp to me. I just don't totally know exactly how we want that to happen. So like this can pick our value and we can just say like print out this dx. Like if dx is, you know, within 32 pixels. So we have like a value from 1 to 0 now of like how close we think the player is. I think the next thing we could do is actually flip this value and do a square. So if we do 1 minus that value, and then like multiply it back into whatever the actual pixel amount. I feel like I'm making this way more complicated than it needs to be. Okay, let's try to finish the game. Okay, so I need to reprioritize a little bit. This would be great and maybe a polished thing, but what's like the simplest thing we can do right now? Let's just say if you're in the region, we'll just move it slightly towards you. I think we kind of actually just want to pick the point between the two. I think that's actually exactly the math that we want. So on the x direction, I think all we need to say is like, we'll blend between dx 0 and, well, let's just type out all the stuff and then we'll think about how it compresses. So we want to blend between our center, the player's center, by a factor of how far along this path we are. And then that should be our value. Maybe we should make this like v off x. It's almost just like a magnetism type effect. So like that, right? So here's us as far away as possible. Then we get a little closer. And we need the signs to work out actually a bit better. Wait, yeah, what's up with the X sign? So we moved correctly on this side, but on this side we're actually moving like further away. I think our origin points are not correct here. Because it's saying like our origin is like over here someplace. Yeah, again, I think I'm way overcomplicating this. I think literally all we wanted to do was just like something like this. I should probably like sit down and think about how the math actually works out on this. Okay, you know what? I don't know. This is like, I thought this would be like a quick little thing. And I do want to just kind of focus on trying to finish the game, so... Like, I know roughly what I need to do. I feel like I just need to, like, sit down and sketch out the math and, like, play with it a bit. But all we're trying to do is pick a center point on a line. Like, I don't know why my brain doesn't want to think about this right now. So we should just be able to, like, lerp between the 2 points. All right, one last attempt, and then we're moving on. What's our blend coefficient? That's the tricky part. Where'd our strawberry go? So what are we saying should be the value? Okay, that looks like way off. Oh, and then we just need this to be like oriented around our center. Again, I think this definitely compresses a bunch. But yeah, that's starting to look a bit like the right thing. You know, it kind of like moves away from you actually, which is sort of the opposite effect. But yeah, all we needed to do was pick a point like along the line between here and here. And like lerp just allows you to like smoothly blend between 2 values. I was like way overcomplicating this problem. That's all we need to do. And then this can be like whatever factor, like however much you want it to move. So maybe we invert the whole value, or maybe we just invert in the x direction. Let's try invert the whole value, see what that looks like. So it kind of moves towards you. I think it's a little confusing because the sine wave stuff is happening. So let's just turn that off for now. So right now it's kind of moving like, I think actually, yeah, we don't need to invert it. It looked totally fine this way. Like it's almost like running away from you a bit. Yeah, but like it does sort of wind up back in the center. Okay, I think that's literally all we wanted here. That looks good enough. And then all we have to say here is just like, well, if there is no player because they maybe died or something, then just reset. Like, just move our visual offset. So this will actually step every frame to 0 at some rate. And this is kind of in like pixels per second, so actually we should totally move our V offset to that. Like that'll look a little better too. If we just like step it towards it at some sticky rate or something. What's the deal with move? So we've got to move. For some reason I commented out this move. Min, max, and we can just drop it down here. Yeah, it's still a floating point amount. Still here, by the way, just kind of zoned out watching you code. Yeah, sorry, I feel like this wasn't as refined as I would have liked it to be, but, you know, I guess that's part of the fun of streaming. Maybe this is like acceleration. I don't know like what this value really should be. See, like that starts to look a little bit better. It's kind of like blending towards you a bit. I think the amplitude on this like is a little too high. And maybe the, like, should it go slower? I guess I kind of like that rate. So it's kind of like moving towards you and then you get closer and then goes back towards the center. Right? Like that's kind of all we wanted to do. Sometimes like it's hard to think about things even if you've been programming for so long. Everyone struggles. I guess we can just say like, we can just factor this out a bit. So we can say like target V off. Because these are just the same block. So we just want to move to that target point. That's all. Okay, now we want to have some like we want it to like collide with you, and maybe it'll turn white or something for a frame or two. I don't know. You'll just collect it for now. That's totally fine. I do want to take a quick break and heat up some coffee. Elite Monkey 0388. Like, does all this seem reasonable? Like, is there anything that you're like it's like you just kind of work through the thing until you figure out what you need to do. Yeah. Okay. I'll be right back, but then we'll make it when we come back. We'll make it so that you actually collide with the strawberry, it disappears. Maybe we'll have some sort of global score. I don't know. I think the only point of collecting these is just I don't understand much, but yeah. Yeah, it'll not make sense for a while and then things will click. You've kind of just got to have some persistence. Power up? Yeah, we could do a power up. I was kind of thinking these are just like strawberries, like in the Celeste sense, where you collect them only to say that you mastered the level and not like you just get internal value. Being able to control left right for 3 seconds. What do you mean control left right? Like fly left and right or something? Yeah, it's that this is just for 100%. Like, I think it's nice to have Easter eggs in a game, even a small game like this, which is why, like, I feel like in my mind this is like part of level design and polishing up like the end state of the game. So I think it's important to like start to think about, okay, if a normal player runs through this map, what are they gonna do? And if a hardcore player runs through this map, we can start to have like hidden regions of special stuff behind them. And just kind of thinking about like how that is gonna work. You know what I mean? And then also I want this game to be able to be speedrunned. So we do have some cool speedrunning strats. Sort of. I don't know how cool they are. I'm not a speedrunner. Where someone made a game where you can control left, right. Oh, okay, like all you can do is jump. Yeah, no, here we're just you can do everything a platformer. We've got attack. We do have the shoot motion, which I think is going to be a power-up. I don't think they're going to start being able to shoot bullets, because it kind of makes some of these enemies like way too easy. Like I can just stand back here and like snipe. Yeah, you can wall jump. So I can like glide against the wall, or I can like it's a little tricky, but you gotta like switch directions and jump in one frame. I should probably make the timing a bit more forgiving, but yeah, I agree. I think one thing that's been hard, like if you're trying to just think about game design here, like I want to strike a balance between a fun platformer and a fun like action game where you're like slashing stuff. And maybe that just means we need to have some levels that are like, okay, you're totally just like attacking here. There's no platforming really. And then other levels that are more like technical and you have to be really precise with your jumps and stuff. Because some of the maps my friend was designing was crazy. I could show those off when we get back, but they're like absolutely nuts levels. And we gave it to some playtesters last night, like some of our friends, and they were like maybe taking a middle ground between these two approaches, because the crazy levels were crazy intense and the easy levels were like too easy. So I'll just show you what I'm talking about here. So let me just, we don't have like a world select or anything. Right now you just have to rename the file. Like, right, this is our folder with all the assets, and if I want to load a game, I just have to, well, wait. We just rename this to world. And then this is the one, the map we're gonna load up. It's a nuts level. Like I can't even beat any parts of it. I can beat some parts, but it's like, here, I'll show you. So where's the player spawn? Okay. So, like, it looks fine. And you're like, oh, this is kind of the same as the old game, right? It's like just the same type of level. And kind of, I mean, I did add some stuff that will make this a little easier. But then it goes like to 11 right away. And it's like, oh god, you gotta like do this crazy platforming. You've gotta like run down here. And the levels only get harder. Like, this level's just nuts. Like, I already took damage. And like, man, it's just like, he designed like a torture game. And I don't know if I like playing these kinds of games. You know? But I did tighten up the physics a bit, so it does actually make this a little bit more reasonable. Fuck. Yeah, I'm gonna die. Oh my god. It's just a really hard game, right? Like, it's a very different type of game. But I think, like, taking a sort of middle ground between the two styles would be kind of fun. Where, like, you have some stuff that you have to do this really tight platforming on, and then you have other stuff where you've got to, like, just kind of run around through rooms and kill stuff. I don't know what you guys think about this style game versus the more open world style game, but, you know, we're at least exploring all the possibility space, is what I would say. We're not leaving much unturned. And I don't want to, like, spoil too much of that, but we'll go back to our other world. So this is just, like, kind of the overworld, but also kind of me just playground stuff. Alright. You like the open world more. Yeah, me too. I'll also be right back. I'm going to take a quick 5-minute break, and then we'll work on finishing up the strawberry. So, let's see. So, 5-minute break. Then, finish the strawberry. And, better lives /spawn system. So I think these two things are kind of like the most important last things to do before we sort of switch gears and just do more like level design. So I'll be right back, but let me know if you are curious about how anything works here or have any questions about how the game works, how the game engine works, why this project exists. Right, yeah, good. Thanks. Yeah, it might still be kind of early in your programming career to like. If you're just along for the ride, then that's totally cool. But I'll try to explain anything as best as I can. If you're, what time is it in my area? So right now it is 3:33 p.m. I'm on the East Coast time in New York City. EST. Okay. So we want to finish this strawberry. We want to finish the strawberry situation. And we've got these like kind of collectible things that we're going to hide in the game. 9:30 p.m. here. Yeah. That's a more reasonable time to be streaming or watching a stream, right? Like assuming you have like job stuff or stuff that keeps you busy during the day. I do kind of want to like slow down a bit the further you get away. Right now it's kind of like, it would be cool. Oh, 15. Oh, wow. Okay, yeah. I started programming when I was like 11 or so, so like, there's still a lot of time to get better at it. It's just, how are sprite PNG converted to map for games? Time reveal. Okay, so yeah, it's pretty basic, like for better or worse. We just have a color palette that the whole game is using. And so the world gen, like I can show you how this world gen works. We just have that image and then we go through pixel by pixel and, well, first we see like if it's totally transparent, we ignore the pixels. But then we literally just match on color. Right? So like this maybe looks like nothing to you, but like we just take the color, the hex code, we paste it in here, and if it's exactly that RGB color, then it creates a tile. Now, there are some caveats to how the system works. Like, you can see we've actually got like 8x8 tiles and 16x16 tiles. So, it's not totally a perfect system. Like, I'm just saying, like, hey, if I'm on a 16, like, if I'm on an even multiple of the grid, because the actual image file is just a smaller version. Here, 1 pixel equals 8 in the game. And that's it. That's all we do. We just go through every single pixel in the map, and then we pick points. There is some sort of special logic here for how the fake walls work. But yeah, I mean, the goal was just to try to finish something really quickly, so I didn't think I had a lot of time to, like... Normally, I would make my own editor, and then that would really make it a much nicer editing experience. But this isn't so bad. Like, I definitely think we've been running into some of the limits of the system now, where, like, okay, I ran out of 16 colors in our 16 color palette, so then I also just started picking other random colors that hopefully look unique enough. But one kind of fun, like, side effect of this is, like, the world files kind of just look exactly like the world. So that's kind of cool. Like, you can literally just share this image with someone and load it into the game and it'll work. Obviously, the downside is, like, there's no documentation for what colors what and all that stuff, but yeah. This is how it works. And then in terms of loading the PNG files, I don't have my own parser for that. So we just call into STB image to load them. I did write a TGA parser, just in like a really simple one, not the paletted case. But I just didn't want to like spend too much time doing that. Otherwise, we try to write all the code ourselves, and like for the most part we did. But we've got these 4 libraries, which are like Sean Barrett's libraries. They're really good. I'm pretty sure a lot of games use these libraries. Like, so it's nice because it's just one file and it's the whole library, and then we've got one for image, one for printing, one for font rendering, which is not perfect, but for this game, it's good enough. Like, that's how we do the debug fonts, and then one for sound for OGG files. And then, yeah, we just load the image, we go pixel by pixel. That's it. It's the simplest possible thing. Although maybe simpler would be defining the level in code manually, but that would be kind of brutal. Okay, so we want to just make this strawberry be able to be picked up is the next thing. So we've just got these like pickup items that are like, I imagine for like the really hardcore players of this game, and we want to try to like reward them for finding secret passages or like mastering certain moves. So we could make this weight dynamic. Maybe we'll make a note for that. Like visual effects. Maybe just like VFX. So let's just type in the simplest possible code. So if we're colliding at our position with any of the players, so collide at takes an offset. So you can actually like look out. If I randomly generate the distance between pipes and the gaps, top pipe, and then the bird just checks all the corners for the specific green color, and then you die. Yeah, so there's a few reasons you don't want to do that necessarily. Like, you want to make sure that your game is stable at any frame rate. I know you're just learning, but like if you're curious, you want to actually like check every point between where you're moving and where you're going. Because otherwise you can get this effect called tunneling, which is where your character just like jumps behind a wall it's not supposed to be able to jump behind. So like you got to do a bit of work to make sure your game is frame rate independent, which is what we do. Like anytime we use a time value, we're either using the change in frame rate as the rate, or like velocity is in pixels per second. But if we're changing velocity, meaning acceleration, then it's got to be based on the change in frame rate. So that's all based on how many seconds have elapsed in the real world. And then, yeah, our collisions are like kind of dumb, but we can get away with it because it's a pixel game. We just step through, like, if we try to move an actor, we just step through one pixel at a time and check that we don't collide. And if we do, we stop and we're done. So there's like all this like hardening stuff that, like, this function technically is not frame rate independent. Like, I could tunnel through it. But maybe we don't care that much about it. Like, another way of doing it is getting the player velocity, and then yeah, we might just want to do that because it's like a nice little thing. XP is a constant and the pipes are thicker than that, so it shouldn't happen, right? Yeah, as long as you can prove that your speed is never faster than X speed. Like, our physics are a little bit more like fake realistic, so there are some like weird, funny, broken corner cases to them, which I'm thinking will be more speedrunning type things. Like, we're gonna lean into them and make them intentional, but yeah, as long as your X speed is never greater than the pipe thickness, it won't happen. Okay, so let's just say, hey, you got the strawberry. Congrats. Right, so if your Y speed could go faster than the shortest pipe, it's the same problem. But I assume that's not the case. So that's it, right? Like, it just, poof, disappears. Maybe what we want to say is like we're gonna flash white for a bit or something, like. Or we'll have like some timer. So like, let's just throw in a property here for the strawberry. Was collected. And then we're going here, we would say, okay, so we were collected. Oh, actually we can use our state system for this. We can say state equals 1. So if it state equals 1, sleep for half a second, maybe 1 second. Awake. So we have this really basic like state system where you can like say I'm in state 1 of like you can name these if you want, but they're just arbitrary labels. And you can say go to sleep. So like this block will only run if you're awake, right? So we do if we're not awake, we just sort of stall here. And what that allows us to do here is we can say, well, like let's blend the color. So actually we want to do like an RGB lerp, which is lerp sounds really fancy, but all it is just like a smooth blend. So we've got this like RGB. Oh wait, this is in math, right? So like our RGB to HSV. So when you're blending colors, you have to blend. Oh wait, all we can do is just. We might just make another sprite for it, because actually we're not multiplying by this color. Well, okay, we could do this. We just need to change our strawberry sprite. So maybe we'll do that. So we just need to make this a mask, basically, and then we're going to multiply this by the color instead. So if we run the game, we'll see it's white now, right? And that's just to save sprites. Like, we don't need to have 2 sprites, one that's this and one that's that. We can just reuse the same sprite. The only difference is we need to set our color now here explicitly. So we gotta just pick out this color, and it is 255381116. 2551116. And then it's gonna have a solid opacity. We don't really like to cheat in this game. I want to make it as realistic as possible. The only time there are a few exceptions where I'm breaking that rule, and I think they're fine, but I'm trying to make it look as retro as possible. So now it's back to the same color, right? Did you notice the trick? It's the same thing, but we're blending it. So what we could do now is we could actually animate that color if we wanted to. But I think we're just gonna like make it turn solid white for now. And then when we get to the second state, we'll just destroy ourselves. And then like we'll do whatever, make it rainbow. Yeah, we could do rainbow. We would need to define like our color ramp for that. But yeah, you just rotate around the hue. Like if you're doing a HSV thing, you would just animate the hue and then saturation and value stay constant. All right, like let's try to make it rainbow, because why not? You know what? Like whatever. So let me find. I have some old code for some of this hue, saturation, and value stuff. Hue equals hue plus 1. So what I was saying earlier about like everything needs to be frame rate independent, it's kind of like that, but you're not always literally just stepping by one. Like you want to step by some factor based on time. So that if someone was running the game at 120 frames a second or 30 frames a second, you get deterministic results. And so we actually have some debug commands in the game so that you can like test out some of that stuff. But so HSV. So you asked, and we will try it out. All right. I can't promise it's gonna look great, but we will at least try it out. How do you want to make it frame rate independent? Okay, yeah, so every update function takes the delta time. So dt is just delta time, meaning how much seconds elapsed between the previous frame and the current frame. So at 60 hertz, this will mostly always be, 1 divided by 60. So there's like an inverse relationship between frame rate and like the delta time. This is in seconds, I think, or it's either in seconds or milliseconds. I think it's seconds. So it's the change in frame rate in seconds, and then you just have to make your function based on this, right? So like it's a little bit trickier, but like we were doing it over here, right? Like we're moving the offset to this point at this rate, and we're multiplying by delta time. So it's like gonna take, this is like, okay, move 800 pixels per second is kind of, or I guess it's maybe an acceleration at that point. Well, no, it's not acceleration because we're not changing our speed, but yeah, it's a little tricky. I get confused about it sometimes too, but the short answer is, yeah, we just want it to be based on time. So I can show you how it works for like a really simple color. Like if we're just blending between two values, which this is gonna look awful, by the way. And I want to blend with a factor of 0.5, right? So right now I'm just in the code that actually reads the computer time. Kind of, yeah. Like I did program it, but it does actually call the operating system and ask for the time. And like you can see where we compute delta time over here. Like in our main window loop, this is like we're just going all the time until you tell the game to quit. And then we just ask the operating system, what's the current time in milliseconds? And then we subtract the 2 from the previous frame. And then we just feed that through to all of the systems, right? Because delta time is actually in milliseconds, and it turns out app wants to think about it in seconds, so we divide by 1,000. And then app update gets delta time, game update gets delta time, yeah. Yeah, exactly. Okay, so... Okay, cool, yeah. Glad to help out. But so if you want to blend like this value, and you want it to always take a second deterministically, you would need to have some like internal time. And I can just reuse like another thing. So I'm just reusing a variable here, but now it's going to take like always however long it takes to accumulate 1 second into this thing, or really 1 into this thing. And because we're changing it at a rate of the delta time, then this takes 1 second to change between white and red. And you can also do other stuff, right? Like if I wanted it to go back and forth, you could say, okay, well, take the sine of this value, add up by 1, and then divide by 2, so that we're like moving the sine wave between 0 and 1. Because lerp only really thinks about things in 0 and 1. And so now this blends between white and red, and it kind of does like a smooth fade and slows down, and right, it's like just the normal sine wave path. So, like, you could see how we could do RGB with this kind of thing. Like, it's kind of just this, except, if we're gonna go extra, I want to go, like, full extra. You know, I want it to, like, increase in size and maybe shake, like, the screen shakes or something, and then it, like, flashes rainbow colors, and you're like, wait, I didn't think these colors were a part of the game. I don't know. Yeah, I don't know how much time it's worth spending on this stuff. But the quick version is we just have to convert the color space. Like, let's just do the rainbow animation here, and then, like, we'll think about what we actually want it to look like. So, if you're blending colors, we need to convert the color space. No, okay, yeah, you were joking. Yeah, I don't know. I think, like, it can work if you just decide to break certain rules of the color palette. Like, I think it definitely could be a fun thing, but it's not a thing I would do if we're trying to finish this by Sunday or whatever, right? So because we're trying to just finish this thing by Sunday, like, let's try to make more decisions in that way. But yeah, all you would have to do is, like, convert into HSV, do your blend in that space, convert back to RGB just because that's how the game expects the color to look, and then you draw it out. And I think the only thing is HSV just, I forget what, like, units this is in. I think it's just the standard one, so I should probably just copy these in. This code was kind of, like, ported from other stuff, but, right, like, your red, green, blue are in this range, and your hue saturation value is in this range. So your hue is like a rotation around the color wheel. Is kind of what it winds up being, I think. I could just be making that up, but I think that's true. Yeah, I mean, let's just see if we could get it working, right? I think it'll only take like 5 minutes. So color equals RGB to HSV. So we need to convert our color into the right color space. Because blending in RGB looks terrible. Like, you never want to blend in RGB. And then that'll get us the value. So we'll say, like, value equals this. And then we would want to say, like, eventually we want to convert it back. So build a new color from converting this back to RGB. And then solid opacity. Rainbow bouncing balls is a homework. Yeah, that's fun. Okay, so now that the value is in RGB space, we can just blend the hue by delta time 180, value minus equals 180? Does it go 180 to 0 to 180, I think? Value.hue. So, I think, wait, what happened here? There we go. See? You got your RGB hat looking thing. I mean, we can make it faster too. We could say, so if we multiply delta time by 180, it'll go through the wheel once every second. Right? And there you go. I don't know, I kind of like it. It kind of, like, we're not going to have these hidden, and, like, these are going to be hidden. So it's not going to mess up, like, the aesthetic of the game if we say, like, let's just see an example, right? So say I had some hidden region of the game. I have to kind of clobber this grass potentially. So it's hidden, out of view, and say I, like, accidentally fall into this zone, and I'm like, whoa, the hell's this thing? Or, you know, I don't know. I have mixed feelings about it. Because on one hand, it kind of feels like it doesn't fit the game palette. Um, Everyone loves RGB. I don't, I don't particularly care for it, but hey, if you like it, we can keep it in for now. Maybe we'll change it to a color palette later, but. So, okay, yeah, no worries. Thanks for hanging out. So I don't totally know why we're not. Like, we're registering the collision, but we're not switching state for whatever reason. It's a little concerning. So I guess we'll just print out what state we're in. State 0, state 1. Maybe we're getting stuck in a sleep cycle. Yeah. Wait, what? It's like we added this RGB and it totally just broke the game for some reason. So it seems like this should work. I have a feeling it might be a bug with our entity destroy. Maybe if we call this every frame, there's actually a bug. So like, what if I just do this? It's so confusing. So is destroy not killing this entity for some reason? You know what? I know what the bug is, guys. We added this code here. I think, or at least we started adding this code. No. Somehow it's being brought back to life. I don't know. Maybe the RGB just means that we can never destroy it. And that could be true. But it would be nice if we could destroy the entities that we create. Like, you know, we're kind of playing God here a bit. But I felt like this should be totally within our control. So maybe we just need to step through this. So how can we get this code to do the thing we want? Okay. We say sleep for 1 second. Like, that seems pretty straightforward. We're not awake. We can say we're sleeping. We should probably just step through this in a debugger. That's going to be my next tool in the toolbox. And let's like print out, you know, if our flag's alive. If we like died. Okay, interesting. We're getting stuck in a sleep state. You know what the problem is? Entity sleep accumulates sleep. I feel like I never wanted this to be multiple. Like, say like add sleep. I'm never going to use that. We're just going to set this to this. I think because it was colliding for a while, like it was just giving us a lot of seconds to sleep. There we go. Okay. So that was the bug. I knew that that code was going to be problematic, and I just kind of like forgot about it a little bit. So if we're sleeping, so basically if we're alive or asleep, we want to go do some crazy animations here. Maybe this is where we put the RGB. Like it starts out all nice and fine, and then we go RGB. Or maybe we want to like always be RGB, and if you hit it, then like our scale is gonna like move the scale towards 4x4 at a rate of 1 scale point per second. So you're gonna like slowly grow. Well, we need to actually make our draw entity use the scale. I think because I thought it was gonna mostly be pixel stuff, we didn't want this. You know what, let's just move the color to white. Or we'll just do like immediate. Okay, that's good enough. Call it done. Vector 4. Yep. You're exactly right. You know, we can make that animation look cooler, but I'm not too concerned about it. For now, let's just make it kind of like turn white for, I don't know, 200 milliseconds, disappear, and we can have like fireworks or something go off. Okay, I think we're gonna call strawberries done for now. So let's just commit this. Colin, strawberries done for now. And now that we're done with these like hidden collectibles, I guess we need to keep track of how many you've gotten, but we can do that later when we do the menu stuff. We either want to do menu screen or better live system. I kind of want to do the better live system because I think it's more important for the game right now. So the problem that we have at the moment is, like, if I die, I restart all the way back to the beginning. And maybe we want to have a mode where you just restart back to, like, the point where you entered the room from. But then maybe we'd make it instant death, right? Like, I don't know, there's kind of a trade-off there. Like, you can have lives and then you restart here. And if you lose all your lives, then you restart at the beginning of the world. I think that'll start to just feel like a little bit more real. The problem is right now it seems like you could just kind of like make a lot of mistakes and there's not much punishment for that. I don't know. I guess there is. Like, you do get reset all the way back. Well, in either case, we probably want a system where you can get spawned back to the point you entered a level from. So let's just create that, and then we might not use it, but I think we might, probably. So this does get a little complicated in the multiplayer case. Let's just say last good spawn point is 0. And when we switch rooms, so we kind of need to know, like, next offset is going to be this, and game offset equals next offset. So if next offset.x is not equal to game offset.x, or next offset.y is not equal to game offset.y. We might even want to have a way where, like, we just pick these points manually, but, you know, we don't really have time for that right now. So if we're transitioning states, we'll have a thing that's like, you know, needs good spawn point. And so we'll say, like, we need a good spawn point now, please. And what we'll say is the last good spawn point is actually just the point that you entered the room from. Maybe. So we have the player position already. So then all we have to say is, like, well, if we need a good spawn point, and the player is on ground, so we have a function like on ground, then we just say the good spawn point is here, don't worry, you're on the ground, you're safe. So really we'll probably want to, like, move this point to contact the ground, potentially, or this will fall back to a editor picked location. So this is global game offset and global game offset. Okay. So let's see if we can debug this spawn point system. So I just want to draw a rectangle in the last good spawn point, and we'll see if it's getting placed roughly where we think it should. So we'll just say draw sprite, I guess, whatever, who cares. We're going to delete this code anyway. Sprite at global.lastGoodSpawnPoint. And then also needs good spawn point. Yeah, I guess this can just be set in the world. So when we load up a world, we'll probably also just say, like, hey, find the first player. And then, I mean, I don't know how it doesn't exist at this point, but if somehow it didn't exist still. Okay. So you see we have this thing up here. Actually, the last thing is we need to transform this sprite into... So there's a difference between camera coordinates and game coordinates and screen coordinates. So... Okay, it kind of picked a weird... I guess this wouldn't be camera, this would be like game to screen. Okay, so you can see like the pause, it's really tiny, but it's actually underneath our feet here. Which is kind of what we want. And maybe we'll scale this up a bit more. So, which one of these is the scale? We have this now. Draw sprite. Anchor 0. Scale is v244. Right? Like, hey, that's our spawn point. We had ground contact, so it's probably safe to spawn us there. So I want to say that, and then all we have to do here is just set this back. Needs good spawn point equals false. So now we don't need a good spawn point, and that's our spawn point for this map, right? Just that. And that starts to kind of feel like a good type of system. I don't know why this doesn't pick a new spawn point. Maybe we'll just have a special case for 0, 0. And then we need a math function for like 0. Vector 2. Yeah, so maybe we just have like a thing here is 0. V2 is 0? I don't know. Vector 2. Because we have vector 2 equals. At least we used to. Yeah. So we'll have an equals and we'll have a 0. Is 0. This will just be vector 2 equals a v2 0. Right? Like you can't literally check floating point against 0. You need to have some minimum precision. And then this is just vector 2 is 0. And then the last thing we want to say is, well, I think that's fine. I think this is totally fine for now. So let's just see. Okay, we expect it to kind of pick a point here, and it's like not quite doing that. Interestingly, we're not considered to be grounded. I want to make a keyboard key that just like jumps us to that spawn point so we can start to get a feel of like what that feels like. Maybe we'll make this F7 to pay respects. This will just be some update code. It's kind of throwaway code. Doesn't matter. Let's find all of type any player. Find first of type. Yeah. Okay. Right. So now we have a key, and it'll just jump us back to the spawn point. We also want to probably reset the player's velocity and stuff. We probably want to like reload the whole game or something. I don't know. We got to think a little bit about how that's going to work. So say I wanted to reload this level. Okay, yeah, you kind of start here. We kind of want to make sure the player's in bounds when we pick this point. So like right now we're kind of picking a point with you like just barely outside of the region. It's weird that it's not centered. Or maybe it is centered. Yeah, okay, our origin point is actually just the top of that pause text. Okay. We probably want to snap it to the grid. I think that's a good idea. Maybe we'll just do like snap player position to, so we have just like grid size, tile size. So snap you to 16 by 16. We can just hard code it, whatever. And then the trick is we actually want to not just like literally set the position, but we want to say there's like a special function, place entity on grid, player global last good spawn point. Right, so, okay, that kind of works, but it's actually, like inside the ground. So when we're picking that last good spawn point, we want to say like the top of the player, probably. Something like that, maybe. I think place player in world will try to snap 2 coordinates already. I guess we could just subtract the player height. Oof, it is hot here. Not exactly what I want it to be. Well, let's see. We're spawning up here. We kind of want to just find the ground directly under where the player spawns in. And I think that will always work. Famous last words, right? But, you know. So we'll make a little function here called like find ground contact from point. And this will just be the player position. So we'll just do something like that, right? Just kind of make up this function. Find ground contact from so then we just have to fill this function in. We could have it so that maybe it doesn't return points always, but on the worst case, it's going to return where you started. So then all we're going to do is just march down until we find a block at this point. So we'll say solids equals find all of type entity wall. And we've got this entity helper here, collide at. So we'll just want to say like for I equals 0, I is less than game height. If we go higher than the game, then hey, look, we didn't find anything. Sorry. And we'll say if collide at it solids I, then we will say result equals. So this actually should be like auto other equals collide at other bounds. We'll have to like massage this point a bit, but basically we want to say like rect top center. So we want to place you just on the top minus the entity we got in size. Well, we want to shift up by its size and the anchor point, kind of. This is going to need to be workshopped a bit. But something like that. Yeah, so at the very least, we'll just give you the rect top center of it bounds. Okay, rect top center. Oh, center top is XY, right? So oof. And then we just want to march this along like the positive Y direction. We do want to fill in a function called size eventually, but for now this can just be that. Oh, I guess we can do bound size. So there we go. I mean, we're like exactly where we want to be now. More or less. So I think we just want to do this on room transition and on... I think we always just want to... Like, we can get rid of this needs good spawn point nonsense. Like, we're just going to pick a point as soon as we do this. As soon as we enter the region. Okay, so we're definitely picking a weird point there. Okay. We're gonna try to wrap this up soon, so we're picking the point on the ground. It's a little bit way too far down, actually. Oh, we need to say break, duh. We need to exit out of this loop so that we only pick the topmost point. And then, yeah, like you can see, we're kind of getting the right point there. Now, technically, we need to shift this point a bit, but... Like, I'm wondering if this should actually be that. No. Maybe just this. That looks pretty correct. So it's like we're always putting it exactly in that grid tile. Now, technically, because we know we're marching by grid space sizes, these can also... Well, we don't want this to be any, like, yeah, we could have some room for error if we don't just march along by pixels. So as soon as we enter the room, like, boom, you get your point picked, right? Now we don't get a point picked here, and I am a little confused by that. Like, we only get points picked when we're going forwards, not backwards. And then the last thing we want to do is make sure to snap this point also into the camera space. You know what I'm saying? Well, not snap. We just need to make sure it doesn't go outside the room. So we've kind of got these auto positions working mostly fine. We could also just say, like, hey, we're never going to pick points that aren't on the border of a room. And so if you've got no border contact, like, we don't know how to place you. We don't know how to help you. So now what happens if I die? Take some damage. I feel like this invincibility is too long. Okay, and then we die. I think what I want to make happen is if you take any damage, you're out of the room. You failed the room as far as I'm concerned. Like, that should be... Oh, nope, you're back here. Right? So, like, we can actually prototype this now. Come on to here, say I got hit, boom. You're back there. Sorry. Now, as extra punishment, we could have all the enemies respawn. Which kind of feels mean. But that could just be what we do. Okay, so the first thing we need to do is we need to make sure that this point is in the freaking grid. So there we go, right? We're snapping it into the grid. That's looking a lot better. I guess we have to shift up by the center point if we're gonna snap. Well, snap on X, shift up. So we just want to make sure, like, this point is actually the correct point. Yeah. I guess we could convert these to level space, which might just be easier to think about. You know what I mean? So if the points are in level space, then we'll be less likely to make a mistake. It'll be easier to verify that it is correct, in fact. But that's okay. So if our offset changes, what's confusing here is, oh, I see. We're kind of picking a point that's like not totally the correct point. Like when we're snapping to the grid, we're almost getting the grid space one further in the room. Which might be fine. I don't know. It's almost like we want to wait until you're actually in the level. I guess we could just check, like, if this point's in the level. And we could have, like, a level index. So let's say here, like, incomplete. Check if the point is in next level, and now this might actually just be all over engineering. We might just want to say you're going to define the entry points to the region. So we could potentially do that. But I'm going to take a quick break and then we'll wrap it up. You know, I'm just going to wrap it up now. Let's wrap it up. This is a good session. We still don't have a finished game, but we're going to try to get a bunch more done. So, thank you everyone for coming by, and hopefully we'll finish this game soon. I think what we've got is a pretty good prototype at this point, and it's really just a matter of like testing out some of these levels and making them a bit better, and also polishing up some of the existing mechanics we've got. I do want to finish this like level spawn system, so we'll probably figure that out or abandon it potentially. I don't really know, but anyway, yeah. See you all later.